This app is a pathfinding application I call Behavior Systems that I coded using Visual C++ DirectX. I'll just get the application up and running. So it only uses 2D sprite-based features of DirectX. It consists of a player in green, a drone in red, and a group of drones in white. It's called Behavior Systems because each actor displays different kinds of behavior. The green actor is a player actor which I am controlling with the Xbox 360 thumbstick on my Xbox 360 controller. The player actor in green also has some wandering behavior associated with it, so that when the 360 controller is receiving no input, this isn't taken into consideration when deciding on where he should move. The red actor displays seek behavior, namely it follows the player around the screen, and we will talk through how that's done later in the video. All the actors have an avoid behavior associated with them, in that when they approach another object they can change direction so as to not collide. Notice how the white drones don't have an avoid behavior associated with themselves. Just to show you now, I'm going to use a controller to move the player around the screen. I'll do a loop around each of the 4 obstacles, and in the middle of the screen, and navigate through some obstacles with a view to pointing out some of the behaviors we have discussed. So I'm just looping around each one to show how they follow around. You can see how the red drone has a seek behavior associated with it, in that it's trying to seek me, it's following me around the screen. The white drones, they don't have an avoid behavior associated with each other, so they can kind of stack up on top of each other. The green guy is the only guy being controlled by the Xbox controller. I'm using my left thumbstick to do that now. And the other behavior, so we've got seek, seek, avoid, let's see, I'll just go over here a second. Oh yeah, the wandering. So like at the moment, I'm not touching the 360 controller thumbstick at all, and you'll see that they're all just wandering about the screen. There's some code to handle, some logic to handle that behavior too, and we'll talk about that later in the video. So next up is to look at the code for how this is done. This is main.cpp, and the first function to notice here will be winMain. The window is created and dimensionals in pixels declared. So that happens. Whoops, sorry. Let's go back to here. So you can see top left is 0, 0, and bottom right is 800, 600. So the window is 800 wide by 600 high. That's the aspect ratio. Also in this function, an instance of Direct3D 9 is created, which is here. And that's actually a class that I had to write, and I'll show you that in a second. but that just handles the logic for how Direct 3D is doing the graphics that we saw before. And also in this function, the update function is called, which is lower down here, just this one here. Control Shift home, like that. This one. So we'll look at the update and the render functions now. Actually, render is called from a function lower down called wnd-proc. If you see there, the render function. So we'll look at render. Well, actually, yeah, we'll look at update and render, which are at the top of this source code. Update's probably the most interesting one. This is where the updating the position for the sprites before they're blitted into the frame buffer is done, and that's this logic here. This stuff. And render, this is where, but by this stage the sprites have a new position and they're blitted into the frame buffer, giving the illusion that they have moved. So that's what that bit does. And this is really an entry point to the application. So from here we're going to move deeper into the logic that I've written, which are included in all these files here. And we'll take a look at some of that. First off, we'll look at Direct 3D 9.cpp. This is where the Direct 3D instance gets initialized. We don't have to look into this too much because there's a lot of things going on under the hood and it's quite complicated. It's not really that interesting either. So next up to briefly mention is timer. Where are we? Timer. Yep. It includes the timer-based code used by DirectX and the Windows API for drawing the scene, and that's not very interesting either. So next up is game.cpp. So we've got a function down here called render. Oh no, I missed it. Where is it? Update and render here. So this iterates through a list of sprites and blitz each one into the frame buffer. I think blit means block level image transfer, but I could be wrong. And it's just where you're putting the pixel shading data for the bitmaps into the frame buffer and then rendering them on the screen. And because each object in the scene will have a new location, it gives the illusion of animation. That's how it works. The update function, this is where this function updates the position of each sprite based on the expression that is evaluated in actor's update function, and we'll look at the actor class in a bit. That's this one here. Load assets, that's quite complicated for this file, because this creates some sprite objects and stores them in a vector using the standard library and assigns some basic values to them. So that's all this stuff here. They need a set of default values before they'll even appear in memory. And each sprite or each actor in the scene has its own default behavior, and you can see some of that stuff in a bit. Next will be actor.cpp. First we'll go to the update function. This is where we take the actor's position and add a small number based off the direction and speed of the actor. So we're taking the position of the actor. We've got a direction and a speed, and we add that onto the existing position to give the illusion that it's moved, so it's got a new coordinate. So when the object's got a new coordinate in the scene, it appears somewhere else, and when it gets blitted into the frame buffer and presented by DirectX to the user, it appears to move. And that's what the update function in actor does. Render. We'll get into the behaviors later on down the road. The render function renders the sprite's new position by blitting the pixel shading data into the frame buffer with its new coordinates. So you can see these positions here. This stuff is then passed into the render function for the sprite. And actually, if I go to actor.h, you'll see that the sprite is of type sprite, and sprite is the next file we're going to look at, because we'll be able to see how DirectX does its stuff. So the sprite function handles the application's interaction with DirectX. First we'll look at render. It takes the position and rotational value of each sprite from the vector of actors list and calls the draw function, which actually does the drawing of the pixels from the bitmap onto the screen. So the rotational value and position, here you've got rotation, this is position, and rotation and position are passed in as into the parameter list when the render function is called from one of the other blocks of logic in the other source code files. You've got rotation here, this one, and we can see where it actually does the drawing, which is this bit here. The sprite, we just call draw on the sprite, and it draws it on the screen. And the load sprite function, so I've got lots of code because as I was building it, made lots of mistakes, and it was rather lengthy process to go through to get the job done. Load sprite. This is where the bitmap image is loaded into memory so that render knows which pixel shading data to put into the frame buffer. And that's what that does. You can see here there's a parameter called file name, or an object of this type, and it's got a variable name, file name associated with it, and that's where I actually pass in the bitmap image, which is just this thing here. I can probably bring that up in a separate application. That's all it is, just a little arrow. And you can fiddle around with the colours and all sorts when you're loading the sprites. Next up, I want to briefly mention Vector 2D. This is an STD vector, like the standard library version of Vector that comes with C++. This is just my own custom-made type for handling the coordinate system of the sprites for the scene, for the objects in the scene. Had to code that by myself. XNA, Microsoft XNA and C# offers built-in types for handling coordinate systems for actors, but I had to code my own little routines for this app. And now we'll get onto the behaviors, which is the interesting thing. First, we'll look at the Gamepad Behavior. This is fairly simple. This code here, just you'll see this bit establishes some kind of link, because Xbox stuff is part of DirectX. Sorry. So this code establishes like a link with the Xbox 360, and then you just get value. You assign values from the thumbstick to some variables here, which are just floats, and then you use them. Apply a weight to them, and then modify the direction of the actor or the player actor using these values, and that's what gives the illusion of animation. Like the actor is following along with whatever your thumb's doing on the 360 controller. Next up, we'll look at wander, seek, and avoid. So wander first. This one. Whoops. So this works by getting a random value for direction and applying a weight to it to modify the actor's direction. So you can see this get random direction. That's a function that returns a random value, and then we can modify the direction, basically change the direction of the actor, which is the player in this. The player actor is the only one that uses the behavior wander source code, and that does that. Seek, we'll look at that. Behavior seek. So this homes in on a player actor by using the coordinates of the player actor as a target and subtracts its own location from that, applying a weight so that movements are small, but it looks like they are following the drones. So we've got a target direction. So the target has a position there, the actor has a position. We're subtracting them from each other to get a small value. We normalize it, and then we add this onto the direction for the actor. Well, in this case, it would be the drones. The drones basically change their direction depending on this logic, this expression here, which gets evaluated and assigned here. Next up is the avoid behavior. Avoid this for the player and drones to modify their position if they become near to an obstacle so that they don't pass through it. This is done by knowing the target's direction and adding its own direction with a small weighting so that it skims away from the target. You've got the actor's position, which will be anything, the green guy, the red guy, or the white guys. You subtract that from the target position, which is any other obstacle in a list, and you basically apply a weight to the direction so that it basically skims off the direction that the actor's going in, so that they don't collide, and that's basically what that does. So you might notice lots of problems with my code. Since studying C++ primer and working with the guys on #C++ basic on Freenode, I realized I was using the heap to dynamically allocate memory using this notation here, this stuff, instead of the dots, to jump between blocks of logic in the different files. This means that I had to use delete more than I needed to, and really should have just been using the stack and dot notation, which isn't shown on this page. But basically, a lack of knowledge from not reading a programming manual before attempting a graphical application created huge headaches with memory, because I wasn't deleting when I should have been, and repeated iterations through the render loop was using all my system memory really fast, and then the computer would crash. So it was really hard to get this code up and running, and basically I should have read a manual before I even attempted it. But you know, if I was to do this app again, I'd do it completely differently. You know, because I've read C++ primer. So I think that's it, guys. Hope you enjoyed it. Bye.